Good morning, friends, and welcome to another class. Today, we'll be looking at the classification of matter. Okay, so let's start. So, we have matter. It can be classified into two main groups. We can have pure substances and can have impure substances. So, we're going to distinguish between pure substances and impure substances. Compare them. So, let pure, then we have impure. Now, the first distinction between the two is this. Let me use an illustration or a diagram to illustrate this. So I'll draw something like this. This is a substance. Now, this substance is made up of 6 units. So 6 units of particles came together to form this substance. Let me call these units A, and A, and A. I realize that those particles are of the same kind and they join together to form the substance. That's what pure substances are. So pure substances are made up of the same kind of particles. So that's why elements are considered pure substances. Remember, elements are substances that are made up of the same kind of atoms. So if this substance is made up of the same kind of particle, it is a pure substance. Let's look at impure substances. I'll use the same illustration. So this substance is made up of 6 units. So A, 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 along the line, I'll put a B somewhere. Now, this substance is impure because we have an impurity B that is different from the other particles. So, in impure substances, you might have different kind of particles that join together to form it. So, note, whilst pure substances are made up of the same kind of particles, for example, elements which are made up of the same kind of atoms, impure substances are not made up of the same kind of particles. The particles will be different. So that's the first distinction between pure and impure substances. Let's look at another distinction between them. Clean this. Now, the second distinction between them is that of the composition of the substances. So let me make it clearer this way. The components of pure substances are always in a fixed ratio. They are always in a fixed ratio. The component of impure substances are not in a fixed ratio. The ratio varies, and we will realize what that means very soon. Let me use an example to explain that of the pure. So we have water. Water always contains hydrogen and oxygen. And as you can see from the water formula, the hydrogen and oxygen would be in the ratio of 2:1. Now, water anywhere in the world would have hydrogen and oxygen in this ratio. So if you bring water from Asia, from America, from China, from Australia, from India, all of that water would have component hydrogen and oxygen in the ratio of 2:1. It will not change. If the water was prepared by me in the laboratory or by you in the laboratory, wherever you find yourself, that water will still have the component being in the ratio of 2:1. So pure substances have their component in fixed ratio. Water is a compound, and in fact, compound, all of them are pure substances. So you just need to take this point. We'll be explaining further whilst I do this video on why compounds are considered pure. But remember that Water is a compound. It's an example of a pure substance. Now, impure substances, however, do not have their components in fixed ratios. Let me give you an example. Let me establish here also that all mixtures are impure. So when you have a mixture of, let's say, water and, let's say, salt, this is a mixture. It is impure, and it's impure because it's a mixture. But whilst pure substances have their component in fixed ratios, impure do not. Now, in this example, the component of this impure substance are water and salt. Now, the mixture of water and salt, let's assume that I'm preparing a mixture of water and salt, and you are preparing a mixture of water and salt. Then let's take a third person preparing a mixture of water and salt. The preparation that we do depend on the quantity of water and salt that we put into the mixture. So I can prepare water and salt solution with more water than salt. You can also do something similar with more salt than water. Somebody will do a water salt solution with equal quantities of water and salt. So you realize that the components of this impure mixture are not in any particular fixed ratio. They change, they vary depending on who prepares it or where you are getting those components or the substance from. So it's another distinction between pure substances and impure substances. Pure substances have their components in fixed ratios, whilst impure substances do not have their components in fixed ratios. Let's look at another distinction between the two. So let me clean this. Forgive me. Okay. So pure substances. Now, pure substances have what we call distinct properties. Let me clean this and write it here. So they have distinct physical properties. Impure substances, on the other hand, do not have any particular distinct physical property. And I'll explain this. Let's take water. Water, you've already established that is a compound and it is pure. Water has a distinct property. One of them is that it's liquid, and water would always be liquid. Now, but another distinct property of water is that it has boiling point of 100 degrees Celsius. Now, this property will never change no matter where you get your water from or who prepared our water. It's distinct to water. That's what actually distinguishes water from other substances. Water would always have boiling point of 100 degrees Celsius. So if your water is coming from India, China, America, Australia, its boiling point would always remain 100 degrees Celsius. It's a distinct property, physical property. What about impure substances? Impure substances do not have distinct physical properties. Their physical properties vary and it depends on the components that come together to form them. So for example, you can have, let's say, a mixture. We know that mixtures are impure substance. A mixture of, let's say, salt and water called a brine. So let's take the first mixture of salt and water. We call it A. Another mixture of salt and water. We call it B. Another we call it C. So first mixture of salt and water might have a boiling point of, let's say, 110 degrees Celsius because the components they vary. The quantity of salt is different from that of water. The B mixture can have boiling point of 115. It will change. C can have that of, let's say, 105 degrees Celsius. So you see, the for impure substances, they do not have any distinct properties. Their properties or physical properties vary based on the component that join together to form them. So that's another distinction between pure and impure substance. Let's look at our final difference between the two. And I'll clean this. That cleaning is taking a lot of my time, but forgive me, let me clean this so I can have that space and write. Sorry. Okay, so the next difference between the two is that pure substances are usually homogeneous in nature, whilst impure substances are usually heterogeneous in nature. So what do these terms mean? I'll use an illustration to explain it. This. Now, let's take again water. It's a compound, it's pure. Water is made up of hydrogen and oxygen. Those are the components of water, hydrogen and oxygen. Now, but if I present water to you and I ask you to observe it carefully, will you be in the position to tell the hydrogen component of water or the oxygen component of water? The answer is no. And the reason is because the hydrogen and the oxygen mixed uniformly together to form a uniform substance. That is an homogeneous substance. So in homogeneous substances, the components mix uniformly to form a single unit. So that's what the homogeneous substances are. What about heterogeneous substance? I'll use an illustration. So we have sand mixed with, let's say, water. It's a mixture. All mixtures are impure substances. So we have a sand component and water component. When I give you a mixture of sand and water and I ask you to observe it, will you be able to tell which aspect of the mixture is sand and which aspect is water? Absolutely, you'll be able to make that distinction because the sand will settle at the bottom while the water will float at the top. And it's because the two do not uniformly mix together to form an homogeneous mixture. That is an heterogeneous substance. There's no uniform mixing. So that's the difference. So whilst pure substances are homogeneous in nature, impure substances are mostly heterogeneous. However, there are some impure substances that are also homogeneous. Let me give you an example. Let's say a mixture of salt and water. Whenever you mix salt and water and you stir for the entire salt to dissolve in the water, and I present that solution before you, and I ask you to tell me which aspect of the solution is salt and which aspect is, will you be able to make that distinction? You will not be able to make that distinction because the salt will dissolve entirely or uniformly in the water to form an homogeneous mixture. So yes, there are heterogeneous i- impure substances and there are also homogeneous impure substances. But the point is this: what is the difference between this homogeneous and dishomogeneous? They are different. The homogeneous nature of impure substances is such that the component involved can be separated by a physical means. And I'll give you an example. For a mixture of salt and water, you can actually separate the two by just applying heat. You apply heat to the mixture and the water will vaporize, leaving behind the salt. So you see, you'll be able to separate the two. You can even use another physical separation method such as distillation to separate the two. You have your salt and you have your water. So you can use physical means to separate homogeneous substances that are impure. However, you cannot do the same for pure substances. Let me give you an example here, the water. If you want to separate the hydrogen from the oxygen, heating the water will not be able to achieve that. Heating is a physical process. It will never separate the hydrogen from the oxygen. It will be impossible for you to do that. You can neither use the method of distillation or any of the separation methods to achieve that. So we can't use physical processes to separate the component of homogeneous substances that are pure. The best you can do is to use a chemical method to achieve that. But a difference you need to note here is that pure substances are mostly homogeneous, whilst impure substances are mostly heterogeneous, although there are homogeneous ones in there. And the difference between the homogeneous substances and that of pure is that the component of the homogeneous impure substance can be separated by a physical means, whilst that of pure substances cannot be separated by any physical means. If you want to achieve that, you would have to use a chemical means to achieve that. So we've been able to establish 4 differences between pure substances and impure substances. What I want us to do is to go back to our chart and continue with our classification. So from what you said earlier on, we've been able to establish that even pure substances can be divided into elements. So we have elements in this group and also into compounds. So we have compounds in this group and we also have elements. And we've also established that impurities are mostly mixtures. Okay, so let's move further and classify elements. So let's do the elements. And they are normally found. So they are also classified further into, you can have those that are metallic, called them metals, and you have those that are non-metallic, so we call them. Then we have those that behave as metals and non-metals. They have both properties, so we call them metal or semi-metals. Okay, so that's the classification of elements. For metals, examples such as you have calcium, you have magnesium in that group. For non-metals, you can have hydrogen in this group. You can even have chlorine in this group. For metalloids, you can have boron in this group. You can even have silicon in this group. So that's how you can further divide elements. Now look at compounds. So compounds, they are usually formed when more elements or atoms join. So we have, let's say, sodium combining with chlorine to form the compound sodium chloride. So this is a compound and it is a pure substance. A pure substance. Now, when we say elements are pure substances, it makes sense. I mean, it's very clear, it's obvious. Elements are pure substance because we all know that they are made up of atoms of the same kind. Now, but what about compounds? We've already established that, but is it really the case? Because we established that pure substances are substances made up of atoms of particles of the same kind. Now, but we have the situation where this compound sodium chloride, which we claim is a pure substance, contains sodium and chlorine. So, are we making sense? The answer is yes, we are actually making sense. And let me point this out. Whenever atoms, in this case sodium and chlorine, join together to form compounds, the compound forms are unique. In fact, they are an entirely different entity that are being formed. So the sodium chloride form is a unique substance with unique properties. Remember, we've established that pure substances have unique properties. So sodium chloride is actually having a unique property that is different from the property of sodium separately and chlorine separately. This is not the same as in the situation of mixtures where the mixture would have joint properties of the component involved. So here the sodium chloride has an entirely different property from sodium and from chlorine. So it's one of the reasons why, although compound might seem as if they contain different components, they are not. And in fact, the sodium chloride you see here is not sodium and chlorine. It's actually a single unit of sodium chloride with a unique property. I will repeat that. Now again, the sodium and chlorine would always be in the ratio of 1:1. It will not change. So sodium chloride, a compound, wherever you find it, would always have sodium and chlorine being in the ratio 1:1. Instead, pure substances have this property. They have they have their component being in a fixed ratio, and the same thing is happening here. So that's the reason you can give for compounds being pure substances, although they might seem as if they have more than one kind of atom. So, but they are pure. That sodium, different kinds of atoms you see there are actually one in a unit. So let's move on. So we are done with compound. We'll be looking at compounds in details in another video. Today's class is just for classification sake. So now let's move on to to mixtures. Because we've done elements, compounds, let's look at the mixtures. So you form mixtures when you have two or more substances joined together. Those substances could be atoms, they could be compounds, it could be anything. You mix them together, but you mix them physically together. So there's no chemical combination of the substances that are being mixed together. We form a mixture. And the interesting thing about mixtures is that the component can be separated by physical means. All right? You can use physical means to separate the components. And earlier on, we said that mixtures can either be homogeneous and they can be heterogeneous. All right? And I remember explaining to you what the term homogeneous means, and the term heterogeneous means. Now, mixtures, whether homogeneous or heterogeneous, come in various forms. So you have a mixture of a solid mixed to a solid, form a mixture. So that is a solid mixture. An example of this kind of mixture would be a mixture of sand and stones. You can also have solid mixed with liquid to form a mixture. This is solid liquid mixture. An example of a solid liquid mixture would be solids such as salt mixed with water, which is liquid. So salt mixed with water to form brine would give you a solid liquid mixture. You can also have solid gas mixed together to form solid gas mixture. And a very good example of solid gas mixture would be smoke. Usually smoke contain carbon particles mixed with air. So carbon particles mixed with air can form smoke. So the carbon particles are solid in nature. Air is gas. So the two mix together form smoke. So that's a solid gas mixture. You can also have liquid mixed with another liquid to form a mixture. So obviously that would give you a liquid mixture. And a very good example is water mixed with another liquid, which is for example kerosene. So water mixed with kerosene, two liquids will give you a liquid mixture. You can also have liquid mixed with gas to give you a mixture, which is a liquid gas mixture. And a very good example is air bubbles. So you have in air bubbles, we form air bubbles whenever air combines with water. So the two will form air bubbles. So air bubble is an example of a liquid gas mixture. Then finally, you can have gas mixed together to form gas gas mixture. So a very good example of gas mixture is air. Air, you know, air is simply a mixture of gases. So you have carbon mixed with oxygen, some nitrogen in there with some rare gases. That all of them mixed together will give you air. So air is a good example of gas mixture. So I think that is it for today. But what we will do is let's summarize everything we've learned. So we've learned that matter can be divided into pure substances and impure substances. Pure substances, we know what they are by at this point, and we also know what impure substances are. If you are to differentiate between the two, you should be able to do that. You know that pure substances, you can have elements in that group, and you can also have compounds in that. Then for impure substances, they are basically mixtures. All mixtures are under this group. And these mixtures can either be homogeneous, homo, or homogeneous, or heterogeneous. Okay, just remember that. Now, then elements, you find them on the periodic table, and they are put into three main groups. We have metals, there are non-metals, and we have semi-metals. False compounds usually are formed when you combine elements without fixed ratio. All right, so that's what compounds are. Examples of elements, you can see aluminium somewhere, calcium somewhere. These are all metallic elements. The non-metallic elements, you have, for example, chlorine, argon, which are gases. Then for the semi-metals, you can have boron somewhere. You can also have silicon. For examples of carbon dioxide, sorry, compounds, you can have sodium chloride. You can also have hydrochloric acid somewhere. For mixtures, we have the various kinds here. We know the types, either homogeneous and heterogeneous. The various forms can be solid-solid mixture. You have an example in the diagram. You can have solid liquid mixtures, solid gas mixtures, liquid mixtures, liquid gas mixtures. You can also have gas mixtures. So these are all examples. And this is where we would end our topic on of matter. And please try and differentiate between this and the states of matter, they are not the same as this. And also building blocks of matter, they are also not the same. And the building blocks, you're going to have atoms, ions, and molecules. And on the state of matter, you're going to have solid, liquids, and gases. All right, we end our lesson here. But for those of you who have not subscribed, please do. I need your subscription to encourage me to do more of these videos. I would have to end here. Okay, see you and take good care of yourself. Bye.